Just imagine for a second. A machine so powerful, it does something that, according to the laws of our universe, just shouldn't be possible. This isn't a movie plot. It's exactly what happened in December of 2024.
So today, we're diving into the incredible story of Google's Willow quantum processor. We're going to look at the calculation it performed and the absolutely chilling questions it left in its wake.
Okay, let's set the scene. We're in a lab in Santa Barbara. There's a chip in there, no bigger than one of your postage stamps, and it's been cooled to a temperature colder than the deepest parts of space. And it was given a task everyone thought was simply impossible.
And that's all it took. 4 minutes and 36 seconds. In less time than it takes to make a cup of coffee, Google's Willow processor solved a problem that should have taken, well, an eternity.
So what do I mean by an eternity? I mean 10 septillion years. That's a 1 with 25 zeros after it. That's how long Frontier, the world's most powerful supercomputer, would need to crunch the same numbers. A timescale, just to be clear, that is way, way longer than the entire age of our universe.
So, you have to ask, how is this even possible? How can a tiny little chip just shatter the limits of reality like that? Well, the answer isn't in normal computers. The answer is deep in the bizarre, almost magical world of quantum mechanics. To get what Willow did, you kinda have to throw out everything you know about how computers work. Because Willow operates on totally different principles. And it all starts with one tiny but incredibly powerful concept, the qubit. You see, the computer or phone you're using right now, it runs on bits. And a bit is simple. It's either a 1 or a 0, on or off. But quantum qubits, thanks to a mind-bending property called superposition, they can be a 1, a 0, or, and this is the crazy part, both at the exact same time. So what does that mean? It means a quantum computer can explore countless possibilities all at once, instead of having to check them one by one. It's like being able to walk down every single path in a maze at the same time. But believe it or not, that's only half the magic.
The other half is something called entanglement. This is where two qubits become so deeply connected that they basically act as a single system, even if they're miles apart. If you measure one, you instantly know the state of the other. It's so weird that Einstein himself called it spooky action at a distance.
Now here's the catch. For decades, this was all just theory. In practice, qubits were incredibly fragile. The slightest vibration, the tiniest change in temperature, would cause them to lose their quantum state. The more qubits you added, the more errors you got, and your calculation just turned into useless static. And that is where Willow completely changed the game. It wasn't just bigger or faster, it was fundamentally smarter. It finally cracked the error problem that had stumped an entire generation of physicists. The head of the project, Dr. Hartmut Neven, put it perfectly. He said, Willow was the first quantum system in history that could heal itself faster than it breaks. Its design was so elegant that it could finally correct its own errors faster than they were being created. The barrier was broken. So on that day in December, they ran the big test. The test to prove something they call quantum supremacy, which is just the point where a quantum computer can solve a problem that is truly impossible for any classical machine. And Willow did it. It passed. It worked perfectly. But then, when they looked at the data, they saw something else. Tucked away in the results was an anomaly, a ghost in the machine, a faint signal that just shouldn't have been there, and that none of their models could explain. Something else had happened during those 4.5 minutes. They gave it a name: residual coherent signatures. Basically, after the calculation was done, the qubits were supposed to go back to normal. Instead, they stayed linked, entangled, for microseconds longer than any known theory of physics said they could. It was like hearing an echo in a perfectly soundproofed room after the sound had already stopped. So where did this extra power and this bizarre echo come from? The leading theory? Well, it takes us out of computer science and deep into the strangest corners of theoretical physics. And honestly, it is absolutely wild. It's called the many worlds interpretation. It's a mind-bending theory that suggests every single quantum event, every choice, splits our universe into countless parallel branches. In these branches, every single possibility actually happens, just in a different parallel reality. And Dr. Neven himself dropped this bombshell. He said that, essentially, there just isn't enough computational space in our universe alone to account for what Willow did. The only way to explain it, he said, was to consider the idea that the computer was drawing its power from somewhere else.
The theory goes like this. Willow didn't just solve the problem here. It outsourced the job, leveraging countless other versions of itself in other universes. Each one solved a tiny piece of the puzzle, and then they consolidated the final answer back here, in our reality.
The implications of this are, you can imagine, absolutely enormous. And the series of events that followed the experiment suggests that the researchers themselves were not just stunned, but maybe even a little bit concerned. Right after the test, there was this strange week of complete radio silence. No big press conference, the data was held back, and then, a month later, a former consultant on the project, a Dr. Mel Petroff, she issues this cryptic but very serious warning at a private conference.
And her choice of words was crucial. Listen to what she said, interfacing with. Think about that. You don't interface with a calculator. You interface with another system. That word implies a two-way street, as if Willow wasn't just computing, but maybe, just maybe, communicating. So let's just recap, because this is staggering. We may have accidentally built a tool that can tap into parallel realities. This forces us to ask what existence even means, and suddenly these huge philosophical questions are now very real engineering problems. And for now, Willow, the most powerful computer ever made, remains turned off.
Which leaves us all with one final profound question. The experiment was designed to build a faster computer, but it may have opened a door we never even knew was there. And if we can now borrow computational power from other realities, what happens when something over there decides to answer back?